Here we're asked to integrate sine of the natural log of x dx. Now this one is going to be a little different. We're going to have to do a substitution first. Then we're going to do integration by parts. We're actually going to do it twice, just like in the last example. But this one has a bit of a twist. And we'll get there momentarily. But I'm going to start by doing a u substitution. And I'm going to let u equal the natural log of x. And you might wonder where I'm going to go with this next part, but I'll explain momentarily. If u is equal to the natural log of x, then e to the u is equal to e to the natural log of x, which is just equal to x. So if u is the natural log of x, then e to the u equals x. Okay? And that will come in handy in just a moment. Also, if u is the natural log of x, then du is 1 over x dx. And if du is equal to 1 over x dx, then I could rewrite this as x times du equals dx. From up here, x is equal to e to the u. So this is the same thing as e to the u du equals dx. Now it seems like a lot of work up front, but it's going to set this up so that we can do integration by parts. So let me go ahead and start replacing things. We're going to have the sine of u now. And then instead of dx, I'm going to write e to the u du. Now we can do integration by parts for this one. So you would choose your u and your v, but if that gets confusing because we just did a u substitution, you can call them different letters. We can call them m and n, and it's just as fine. And I'll do that. So I'm going to let m be sine u. And if m is sine u, then m prime would be cosine u. And n was my other letter, so n prime would be e to the u. So n is e to the u as well. Okay. So integration by parts. You'll notice I'm going to be writing this first integral over multiple times, and you'll see why in just a minute. So we're looking at integration by parts here. Let me write this real quick. So I'm going to have m times n. But I'm going to write the second one first. So e to the u times sine u minus, we're going to integrate n times m prime. So that's e to the u cosine u du. Now, guess what? We're going to have to do integration by parts again. We're going to go down here and do integration by parts one more time. And it's going to look very similar to what I have here. And I'll just still use m and n, even though they're standing for different things this time. If you want to use go back to u and v, that's fine. The variables aren't that important. So this time I'm going to let m equal cosine u. So m prime is negative sine u. And then n prime is going to be e to the u. So n is also e to the u. So let's rewrite all of this out. So integrating. And I'm going to go ahead for this first one, I'm going to put the e to the u in front of the sine u. Since we're multiplying, we can do that. So I have e to the u times sine u inside that first one. Now, I've got e to the u sine u minus, okay, so we're going to do integration by parts here on the second integral. So it's m times n, so it's going to be e to the u times cosine u minus, and we're going to integrate n times m prime, so that's e to the u times negative sine u du. Now I'm going to clean this up a little bit. We've got negative signs all over the place. On the right-hand side, I have e to the u sine u, kind of a sad-looking e, minus e to the u cosine u. So now I've got a negative, and a third negative, so that's going to give me minus e to the u sine u du. And you might be wondering, are we just going to keep repeating this process forever? The answer is no. You'll notice on the left here, I've got e to the u sine u. So I'm integrating e to the u sine u du, and I end up equaling all this. Then I've got minus and another integral, e to the u sine u du. We can combine like terms, okay? I'm going to take this last integral, move it to the left, so that leaves me with 2 times the integral of e to the u sine, let me fix that a little bit. E to the u sine u du is equal to e to the u times sine u minus e to the u cosine u. So now I can just divide both sides by 2. So I've got the integral from of e to the u, not from, the integral of e to the u sine u du equals 1/2 times e to the u sine u minus e to the u cosine u. And since this is an indefinite integral, we're going to do plus c. Now, you might be thinking, okay, finally, we're done. We're almost done. We're almost done. Up at the very beginning, we had done the u substitution. So if I scroll back up here, e to the u equals x, and u equals the natural log of x. So using that substitution, here's what I have. My final answer is 1/2 x times the sine of the natural log of x minus x times the cosine of the natural log of x plus c. So sometimes you might have to do integration by parts more than once, and sometimes if you start to see a pattern repeating, you can approach it like this example.